Hello everyone, I am Ali Jawad and welcome to my YouTube channel. In our today's video, we will start with chapter number 24, that is Introductory Electronics of the Cambridge Syllabus Physics 5054. The topic which we are going to discuss in today's video is thermionic emission. So let us start with that. Niels Bohr is a famous chemist and a researcher who has proposed his atomic model in 1913. According to his model, atom consists of a heavy, dense nucleus with a negative charge particles that are electrons revolves around it. In his atomic model, he has given an idea that when electron revolves around the atom, it does not lose or gain energy. However, when electron receives the energy in the form of light or heat, it jumps from lower orbit to the higher orbit, and that is called the excited state of an atom. However, excited state is not a permanent state. An electron has to come back to its original position. And to do that, electron again loses energy in the form of light or heat. So, when electron absorbs energy, it jumps from lower energy level to the higher energy level. If this may continue and we give electron more amount of energy by heating the atoms or by electricity, the electron will not be able to come back to its original position. Rather than after absorbing energy, it will jump again to a higher energy level. If this may go onwards, the electron will again jump from lower energy level to the higher energy level. And after a while, there will be a certain point where electron will be very far from the nucleus, and it will become very difficult to maintain the forces of attraction between the electron and proton. If this happens, then electron will eventually jump out of the atom, and atom will converted into ion. And since this process is carried out by the therm, which means heat energy, that is why it is called thermionic emission. Thermionic emission is an important phenomena in design of the electron gun. So let us see how it works in electron gun. Electron gun consists of two metallic plates. One is known as anode, which is connected to the positive terminal of the battery, while a filament, which is connected to the negative terminal of the battery, which is called cathode. The glass tube is vacuum because air is an insulator and will not allow electric current to get conducted between the plates, and that is why it is necessary to suck all the air out of the tube. When high amount of voltage is applied to this filament, it gains energy, and according to the Niels Bohr atomic model, when electron gains energy, they jump from lower energy level to a higher energy level. And if this may continue, the electron will jump out of the atom. And that is what we are observing over here. The electrons are jumping out of the filament. Why anode is placed on the other end? Because anode has positive charge. And because of the positive charge, all the electron will get accelerated towards the anode. And due to this, we will be able to observe a sharp beam of light incoming from the cathode and traveling towards the anode. So this is applied in electron guns as well as in oscilloscope. Let us watch a video of a physical experiment being conducted in a lab so that we can see how electron beams appears to us. This is the same apparatus The black discs are there to provide electric field. And when the electric field is turned on, you can see the blue light, which is the electron beam, is getting deflected. Since electrons carry negative charge, so they bend accordingly towards the positive charge. Higher the strength of the electric field, higher will be the bending. You can also understand this in terms of Fleming's left-hand rule, in which we know that the force is experienced by the charged particles in the presence of magnetic field and current. As you can see, in the case of reverse of the polar field or the electric field, now the beam is deflecting in the opposite direction. There are two conditions for this thermionic emission. We need very low gas pressure in the tube because gas is not a good conductor and will not allow the electron to jump out of the cathode. And we also need high voltage because the force of attraction between electron and proton is very high, and electron needs to overcome that force of attraction to get jump out of the atom. So these are the two conditions necessary to observe thermionic emission, and they are implemented again in oscilloscopes and electron guns.
Here is another video in which we can see that how electron beam behaves in magnetic field.
Gas in the tube. The electrons here are moving so fast that gravity is negligible. Watch what happens when I bring a magnet near the beam. The beam deflects, which shows that there is a transverse force due to the magnet on the moving electrons. In general, any charged particle that is moving in a magnetic field will experience this fundamental magnetic force. The beam is horizontal outward. When the magnetic field points to the right, the beam bends downward. When we switch the magnetic field, switch the direction of the magnetic field, the beam bends upward.
We can also understand it in terms of Fleming's left-hand rule. The positive charge is incoming, so the middle finger represents the flow of electrons, while the first finger represents the direction of magnetic field. So magnetic field is inside, while the red particles, which are positive, are coming in this direction, and the thumb represents the force. So the particle will experience the force and move in the upward direction. This will be reversed in the case of electron because the negative charge has an opposite behavior. Thank you for watching the video. Don't forget to subscribe the channel to watch the latest videos on the same topic. Thank you.